Welcome to Day 1 of the Exponent Unit, Scientific Notation and Laws of Exponents, Part 1. You will need the 3 P's as well as a graphing calculator. Today, we will begin with a review of the concept of scientific notation. Recall from Algebra 1 that scientific notation is simply rewriting a very large number or a very small number in terms of a number between 1 and 9.9 with a bar over it, and multiplying this new number by 10 raised to a positive or negative power. We do this in order to save space on paper and make calculations easier, as you will see a little bit later in our examples. For our review example, let's look at 5 times 10 to the 4th power. Remember that what this says is that I take 5, and because the power of 10 is positive, I move it to the right that number of places. In this case, I move the decimal place right 4 places and get 50,000. Similarly, if the power of 10 is negative, I will move the decimal point the same number of places, but this time to the left. So instead of getting 50,000, I will get 5 ten-thousandths. So remember, if the power of 10 is positive, I move the decimal point to the right. If the power of 10 is negative, I move the decimal point to the left. Now let's expand our review and calculate using terms in scientific notation. To make our calculations quicker, we can use a graphing calculator. However, to do this, we must know how to enter in our terms. Let's stick with our review example, 5 times 10 to the 4th. We already know this means 50,000. To check this, we will use our calculator notation. In the calculator, times 10 is represented by the letter E, or on the button, double E. The number between 1 and 9.9 stays the same, and the power stays the same. So to enter 5 times 10 to the 4th, we simply enter 5e4. If I type this into my calculator, you should notice I get the same answer of 50,000 as my output. Now let's practice with this idea in example 1. I am going to rewrite this problem as I would input it into the calculator. Please note that this is not scientific notation, merely a way to show you how to enter it into your calculator with greater ease. I look at the first term and note it can be entered as 1.5e3. I also note that my second term can be rewritten as 3e2. Note that I have kept the parentheses around the terms to make it more clear in the calculator which operations need to be performed. I'm now going to enter these terms into my calculator. Notice that I'm going to keep the parentheses just as they are written on the page. This way, the calculator knows which terms are being multiplied to which and which terms are going to be raised to which powers. I should come out to an answer of 450,000. However, this is not in scientific notation. To make it so, I notice that 4.5 would be my new number because it would be between 1 and that 9.9 with a bar. I also notice that I would have to move the decimal places 5 places to the right. So my final answer here will be 4.5 times 10 to the power of positive 5. In the second example, I am going to do everything in the calculator, and as such, we'll start with the operations in the numerator first. You should have 2.4 e to the negative 7 multiplied to 7.5 e to the negative 2 if you have rewritten this correctly and typed it into your calculator. Notice that I am keeping the parentheses between each term in order to keep them separate. Once I have completed the operations in the numerator, I hit enter, and then I divide the answer by the operations in the denominator. In this case, the operations in the denominator are simply 2 times 10 to the negative third, or on your calculator, 2e to the negative 3, or 2e negative 3. I should get an answer of 9e negative 6, but remember, this is not scientific notation. Remember that the e stands for times 10 to the power of the number to the right. So in scientific notation, this is rewritten as 9 times 10 to the negative 6th power. Next, we will review the laws of exponents. These you should once again be familiar with from algebra and geometry. Remember that all of these laws require you to have the same base or number that is raised to a power in order for them to work. The multiplication law states that when you multiply two terms with the same base and different exponents, you keep the base and add the exponents. In this case, x to the a times x to the b will equal x to the a plus b. The division law says when you divide two terms with the same base and different exponents, you subtract the exponents in the order shown. In other words, if you have x to the a divided by x to the b, you should get the result x to the a minus b. The power law states when you have a base to a power that is raised to a power, you keep the base and multiply the exponents together. In this case, if you have x raised to the a and you raise that entire term to the b, what you should get is a resultant x to the a times b. We shall now do some basic review with these laws. In example 3 and 4, we are asked to simplify the expressions completely. In other words, distribute and reduce as far as we can until no other operations will make the expression simpler. In example 3, we easily see a power rule situation because we have two terms that are raised to another power. Following the power law, the exponents of both terms are multiplied to the power of 6 outside the parentheses. Note that when you have a fraction raised to a power, both the terms in the numerator and the terms in the denominator are raised to the power outside of the parentheses. After simplifying, we are left with x to the 12 over y to the 6th. Since we have no like bases, we cannot cancel any further, so we are finished. To simplify in 4, since we know both the numerator and denominator have like bases, we will first simplify the numerator and the denominator separately, and then, once we have done this, we will simplify the whole fraction. To begin, I'm going to start by simplifying the numerator. I look and I see that I have an example of the multiplication law because I have two like bases with different exponents multiplied together. What this means is that I keep the same base and add the exponents. Here I have y to the 4 plus 3. Once I've simplified this out, I should be left with y to the 7th in the numerator. In the denominator, I have an example of the power law because I have a base raised to a power, which is then again raised to another power. So I keep the base and multiply the exponents together. In other words, I should have y to the 2 times 3, or simply y to the 6th in the denominator. I now have y to the 7th over y to the 6th. I see I have the division law, so I keep the base, subtract the exponent in the denominator from the exponent in the numerator, and I should be left with y to the 1st, or simply y as my answer. Finally, we shall expand on our exponent knowledge by looking at fractional exponents. As the phrase may infer, fractional exponents are terms which have a fraction as the exponent. Today, We're only going to deal with the most basic of these examples until we've had a little bit more practice. So, what exactly does it mean to have a fractional exponent? As many things in math are easier with examples, let's look at an example. Let's say, for instance, you have 4 raised to the power of 1/2. What this tells me mathematically is to raise the base 4 to the power of the numerator 1, which I'll write over to the side. I then take the result of that, and I take the root of the degree in the denominator. In this case, the second root, or in other words, the square root. In my example, I have 4 to the first, which is 4. When I take the second or square root of the number, I get an answer of plus or minus 2, or assuming just positive numbers, positive 2. So 4 to the 1/2 power should equal 2. It also turns out that you can easily calculate this with your graphing calculator using the exponent feature that looks like a mountain or a caret, as shown here. Once again, I'm going to rewrite my example as I would plug it into the calculator. So I have my base 4, and then I use the little exponent feature, the caret. This should put me up into the exponent square. I put parentheses around the 1 divided by 2 in order that the entire power is read as 1/2. So if I bring up my calculator as such and plug in this phrasing, 4 caret parentheses 1 divided by 2 close parentheses, I should come out to the same result as my longhand paperwork. And as you see, I come out to the same answer, 2, or positive 2. Make sure that either way you are showing your work or what you have plugged into the calculator on the paper in order that you get full credit on an assessment. So in other words, on an assessment, you're going to have to write this out. So let's take a look at a couple more examples. In example 5, we have 9 to the 3/2 power. Now we could do it longhand, and doing it longhand gives you 9 to the third, which equals 729. I then take the result of that, and I take the square root, because I'm taking the root to the second power, which we saw in the first example was the square root. I should come out to an answer of 27. However, I'm guessing that many of you are not necessarily going to want to use the longhand, especially if you have a graphing calculator. So, if you wish to use a calculator, you can simply enter into the calculator the base 9 raised to the 3/2 power as shown, making sure to place parentheses around the power so the whole fraction is calculated. You should still receive an answer of 27. Either way, make sure that you show your full work. In other words, you're writing out what you're typing into the calculator in order to get full credit. This way, if you type something wrong into the calculator, it's easily seen what you did wrong. So note on the right, we come out to the same answer of 9 to the 3/2 equal to 27. In example 6, we have a base that's raised to a fractional exponent that itself is not in simplest form. In other words, notice that the exponent is an improper fraction that can be reduced. It is perfectly all right to reduce this fraction as long as the next step has the same base, in this case 16, raised to the result of the fraction reduced. So here, we have 16 is our base, and it's raised to 4 halves. We keep 16 as our base, and we look at 4 halves. Well, 4 divided by 2 reduces down to 2. So what I should have is 16 to the second power. If I plug that into my calculator, I should get a result of 256. Which I can write here. Now, if you're not good with fractions, or if you don't recognize the situation that you can reduce the fraction, it is perfectly all right to write it in the same way that we wrote example 5 and enter it into your calculator as 16 raised to the parentheses 4 divided by 2. You should come out to the same result in your calculator with the answer equal to 256. Either way, once again, you need to show all of your work and write down what you have entered into the calculator in order to get full credit on an assessment. So here are the skills that you should be able to do. If you're having trouble with any of these, please go back and rewatch the video focusing on the skill that you feel that you are struggling with. Until next time, this is Mr. Mackman signing off.